Hello children, let us start a new chapter, Laws of Motion. First we will understand what is motion. In kinematics, we have seen that an object is said to be at rest if its position does not change as the time passes. Here we will say just opposite. An object is said to be in motion if its position changes as the time passes. We will include one more term, orientation. This is related to rotation. Orientation means angles made by any linear dimension of the given object with coordinate axes. So the modified definition will be an object is said to be in motion if its position or orientation or both change as the time passes. Types of motion. There are two types of motion, translational motion and rotational motion. When an object changes its position without changing its orientation, its motion is called as pure translational motion. For example, a car moving on a straight road. When an object changes its orientation without changing its position, its motion is called as pure rotational motion. For example, a rotating ceiling fan. An example of both translational as well as rotational motion can be tires of a moving car. Translational motion can be further subdivided into two categories, rectilinear motion and curvilinear motion. We have already read two chapters in kinematics. Motion in a straight line is related to rectilinear motion and motion in a plane is related to curvilinear motion. Motion in an object is caused by an external force or forces. So we need to understand force first. Force is an interaction between two objects as the action of one on the other in the form of push or pull. It tries to bring out change in motion of both the objects. Force on both the objects is action-reaction pair. Any one can be called as action and the other one reaction. For example, when you try to push a table applies equal and opposite force on your hands to resist any change in its position. Force is a vector quantity. It has magnitude as well as direction. To predict how a force affects the motion of an object, we need to know magnitude, direction, and point of application of force. Consider this is an object. A force F is applied at point P. So P is point of application of force. Direction and point of application of force decide line of action of force. So QR is line of action of force. Now, point number one, magnitude and direction decide the translational motion of the object. Point number two, magnitude and line of action of force decide the rotational motion of the object. So you can sense that this object will have translational motion as well as rotational motion. Rotational motion because line of action of force is not passing through center of mass. We will talk more about rotational motion in respective chapter. Force is represented by capital F. Its unit is Newton. 1 Newton is equal to 1 kg meter per second square. Types of forces. There are two types of forces, contact forces and field forces. When one object applies the force on other, when both of them are in direct contact, this type of force is known as contact force. For example, normal reaction, tension in a string, and friction force. When one object applies the force on other without being in direct contact with each other, this type of force is known as field force. For example, gravitational force, electrostatic force, and magnetic force. In this chapter, we will consider only gravitational force, as every object experiences gravitational pull towards Earth, and that is considered as its weight. Newton has given three laws of motion that tell how forces affect the motion of an object on which they work. First law gives the concept of force, inertia, and inertial frames. Second law defines force, and the third law gives action-reaction force pair concept. First law. As per this law, every material body has a tendency to maintain its state of rest or uniform motion in a straight line. It is quite clear that if a body is at rest, it can be moved by the application of an external force. Though it is not clear why uniform motion in a straight line part is included in the statement. We will understand this when we go through the second law of motion. Now let us understand inertia and inertial frames. Inertia is the tendency of a material body to maintain its state of rest or uniform motion in a straight line. In inertial frames, only the forces acting on a material body are responsible for any acceleration caused in it. Second law, as per this law, the rate of change of linear momentum of a material body is equal to and in the direction of net applied force. Momentum in simple terms means mass in motion. If a material body has certain mass and it is in motion, then it will have momentum. Momentum is a vector quantity and it is represented by letter P and given by the formula P is equal to mv, where m is mass of material body and v is its velocity. If we differentiate both sides of it with respect to time, we get dp upon dt is equal to d by dt of mv. M is constant, so it will be taken out. So right hand side becomes m dv by dt. And we know that dv by dt is equal to acceleration a. Left hand side by definition becomes force F. So we get this formula F is equal to ma. If A is equal to 0, that means applied force F is also equal to 0. Zero acceleration means uniform velocity. That is why it is included in the first law of motion. Third law, as per this law, every action on a material body has equal and opposite reaction on the other body participating in the interaction. If you push a table, table will apply equal and opposite reaction on your hands to resist any change in its position or orientation. Let us understand what is a free body diagram. A free body diagram is a pictorial representation in which a body under consideration is assumed isolated from rest of the system. To draw a free body diagram, it is a two-step procedure. In first step, isolate the body from rest of the system and draw in its actual shape and orientation. In second step, show all the forces, whether they are contact forces or field forces acting on the isolated body. We will draw a couple of FBDs in a while. Meanwhile, let us talk about contact forces and field forces. Field forces. We have read there are three field forces: gravitational force, electrostatic force, and magnetic force. In this chapter, we will talk only about gravitational force that acts as weight of a material body. Every material body on this planet experiences a gravitational pull directed towards the center of the earth. On material body, it acts at its center of gravity. It is assumed to work uniformly throughout its volume. That means its center of gravity and center of mass coincide. Furthermore, if the material body is uniform, that means its center of mass lies on its geometrical center. So weight of the body works on its geometrical center. It can be represented in either of these two ways. Suppose this is material body and this is its geometrical center. Then weight can be shown in either of these two ways by vertical arrows. In first figure, head of the vertical arrow coincides with geometrical center. In second figure, tail of the vertical arrow coincides with geometrical center. Contact forces work at each contact point of two bodies as action-reaction pair. For example, tension in a string and normal reaction. Now let us see how to show various contact forces in different scenarios. First contact force that we will consider is normal reaction. Normal reaction always works perpendicular to the surface. Suppose a block is kept on smooth floor. Smooth floor means frictionless floor. We don't need to consider friction between this block and the floor. This is contact area. At each point in this contact area, due to weight of the block, force keeps working vertically downwards. Suppose resultant of all these forces is represented by N. So N is the force due to block on the surface. Applying Newton's third law of motion, floor keeps pushing the block vertically upwards with equal and opposite force. So this force N is the force due to surface on the block. To draw the free body diagram of this block, we need to isolate this block from the system and draw it in its original shape and orientation. Next, we need to show various forces acting on this block. N is the normal reaction that is applied by the floor on this block. W is weight of the block that works at its geometrical center. In this scenario, a sphere is kept on the floor and it touches the wall. There are two contact points. First, where the sphere touches the floor, and second, where the sphere touches the wall. This normal reaction N1 is the force applied by the sphere on the floor, and this normal reaction N1 is the force applied by the floor on the sphere. This normal reaction N2 is the force applied by the sphere on the wall, and this normal reaction N2 is force applied by the wall on the sphere. To draw the free body diagram of this sphere, we need to isolate this sphere from the rest of the system and draw it in its original shape and orientation. Next, we need to show various forces acting on it. N1 is the normal reaction that is applied by the floor on the sphere. N2 is the normal reaction that is applied by the wall on this sphere. W is weight of this sphere that works at its geometrical center. Now let us see second type of contact force, that is tension in a string. Consider a block is kept on a smooth floor. It is connected with a light string. At point B, a man is pulling this string. When a string is taut, a tension force T is created in this string, which works along the string. This is the contact area between the block and the floor. This is the contact point between the block and the string. This is the contact point between the string and the hand. This normal reaction N works perpendicularly downwards because of the weight of this block. This normal reaction works perpendicularly upwards because of the floor on the block. This tension force T works on the block because of the string. This tension force T works on the string because of the block. This tension force T works on the hand because of the string. Now we will draw FBD of this block, string and hand. To draw the FBD of this block, isolate this block from the rest of the system and draw it in its original shape and orientation. Now we will show various forces acting on it. N is the normal reaction created by the floor on the block. T is the tension force created by the string on the block. W is weight of the block that works at its geometrical center. String is light, so we don't need to consider its weight. This end of the string is connected with block, and this end of the string is connected with hand. This is the tension force created on the string by the block, and this is the tension force created on the string by the hand. String is pulled by the hand, so this tension force T is created by the string on the hand. Now let us consider third scenario in which a string passes over a pulley. Consider this is an ideal pulley. That means it is massless and frictionless. It rotates freely about its axle. This is a string that passes over this pulley. Two blocks M1 and M2 are attached to two ends of the string. We will draw a BD of M1, M2 and this pulley. To draw the FBD of block M1, we need to isolate it from rest of the system and then show various forces acting on it. Tension T is created on it by this string. Weight of this block works vertically downwards at its geometrical center. Similarly, we can draw FBD of block M2. To draw FBD of this pulley, we need to isolate it from rest of the system. Since this is ideal pulley, we don't need to consider its weight. String is touching this pulley all along this curve AB. Consider a point P on this curve. Tension force acts at this point towards the center of this axle. We can resolve this force into horizontal and vertical components. Horizontal component of forces on both the sides will cancel each other. Vertical components will add up to tension T on one side and T on the other side. So at the center, it will be 2T that will work vertically upwards. Now let us see spring force. Consider a massless spring which is attached to the wall. Its free end is held by a man. So there are two contact points. First between the wall and the spring, and second between the hand and the spring. We will consider two cases. First, when spring is compressed, and second, when spring is elongated. When spring is compressed, force is applied by the hand on the spring in this direction. As a reaction, equal and opposite force will be applied by the spring in opposite direction. So compression is in this direction and reaction force by the spring is in this direction. They are in opposite directions. In case 2, when the elongation is in this direction, that means force applied on the string is in this direction. So equal and opposite force as a reaction force by the spring will be in this direction. Elongation is in this direction and reaction force is in this direction. They are in opposite directions again. So the relation between reaction force of the spring and its deformation is given by F is equal to minus Kx, where K is spring constant, minus because reaction force and deformation of the spring are in opposite directions. This is known as Hooke's law. Now let us see this question based on free body diagram. Draw the free body diagram of mass m1 as shown in the figure. Assume all the surfaces are frictionless. In this figure, a wedge is kept on the floor. A sphere is kept between the wedge and the wall. We have to draw a free body diagram of this sphere. First, we need to isolate this sphere from rest of the system and draw it as it is. Then we have to show all the forces acting on it. This sphere is in contact with wedge and wall. These are the contact points. So at contact point, normal reaction will work perpendicular to the surface. So normal reaction N2 will be like this, perpendicular to this surface. And at this contact point, normal reaction will be like this, N1 perpendicular to the wall. Weight of the sphere will work at its geometrical center. So this is FBD of M1. Suppose we have to draw FBD of M2. Then we have to isolate M2 from rest of the system and draw it as it is. Then we have to show various forces acting on it. N3 is normal reaction by the floor on the wedge. N2 is normal reaction by the sphere on the wedge. M2G is its weight that works on its geometrical center. So this is FBD of M2. Now let us understand translational equilibrium. An object is said to be in a state of translational equilibrium if it is at rest or moving with uniform velocity. Furthermore, it can be categorized as in static equilibrium or dynamic equilibrium. If object is at rest, it is said to be in a state of static equilibrium. If object is moving with uniform velocity, it is said to be in a state of dynamic equilibrium. In both the cases, acceleration is zero. That means no net force applied on the object. So condition for translational equilibrium is summation of F external is equal to 0. If X external is resolved along the 3 coordinate axes, then summation of Fx is equal to 0, summation of Fy is equal to 0, and summation of Fz is equal to 0. If only one external force is working on an object, then it cannot be in a state of translational equilibrium. If two external forces are working on an object, then for the object to be in translational equilibrium, they must be equal and opposite in direction. If 3 forces are working on an object, they must be coplanar and work along the sides of a triangle in cyclic order like this. Let us see this question based on translational equilibrium. A block of mass m rests on a smooth slope tied with a string as shown in the figure. Calculate the tension in the string and normal force on the block. This block is resting on this slope tied with a string. First, we will draw FBD of this block. So we will isolate this block from rest of the system and draw it in its original shape and orientation. Weight of this block is mg that works vertically downwards at its geometrical center. Tension force T works on this block because of string. Normal reaction N works on this block because of slope. We will resolve mg into two components. one along the slope, another perpendicular to the slope. So along the slope component will be mg cos 30 degree and perpendicular to the slope component will be mg sin 30. Now we will equate t with mg cos 30 and n with mg sin 30. So t is equal to mg cos 30. Value of cos 30 is equal to root 3 by 2. So t comes out to be root 3 by 2 mg. N is equal to mg sin 30. Value of sin 30 is equal to 1 by 2. So n comes out to be 1 by 2 mg. Now let us understand translational motion in accelerated bodies. In inertial frames, acceleration in an object is created only by the external forces. Suppose this is an object and there are many forces applied on it. F net represents vector sum of all these forces. Then this object will be accelerated along F net. F net is equal to mass into acceleration. And F net is represented by summation of all the forces. So summation F is equal to ma. If this force is resolved along three axes x, y and z, then summation fx is equal to max, summation fy is equal to may and summation fz is equal to maz, where ax, ay and az are components of acceleration along x, y and z axes respectively. Now let us see this question. Three identical blocks A, B and C, each of mass m kg, are connected by light strings. Block C is pulled by a force F. If tension in the string connecting blocks B and C is T, calculate F, tension in the string connecting blocks A and B, and acceleration of the blocks in terms of T and M. These three blocks are identical. Their mass is m kg. They are connected with two light strings. Block C is pulled by force F. We have to calculate F, acceleration of these blocks, and tension in this string in terms of tension in this string and mass of these blocks. First point to be noted here is these blocks are identical. These strings are taut. So these blocks will move with same acceleration. If the acceleration of these blocks is different, then these strings will not remain taut. Suppose the acceleration of these blocks is A and tension in this string is T1. We will draw FBD of these blocks. This is FBD of block A. Weight of this block is mg, that acts at its geometrical center. N1 is normal reaction by the floor on this block. Tension T1 is created by this string on this block. So N1 is equal to mg and T1 is equal to mass of this block into acceleration of this block. So this is equation 1 and this is equation 2. This is FBD of block B. mg is its weight, N2 is normal reaction by the floor on this block, T1 is tension created by this string on this block, and T is tension created by this string on this block. Since the block is moving towards right, so net force will be towards right. So net force will be T minus T1 and that will be equal to mass of this block into acceleration of this block, that is equal to ma. N2 is equal to mg. This is FBD of block C. Force F is working towards right, tension is created by this string, mg is its weight and N3 is normal reaction applied by the floor. So F minus T is equal to m into A and N3 is equal to mg. So we have formed all these equations. We can solve equation 1, 3 and 5 to get A, T1 and F. A comes out to be equal to T by 2m. T1 is equal to T by 2 and F is equal to 3T by 2. A weighing machine measures the force exerted by an object on its upper surface. Let us see a couple of questions based on it. First question, a man is standing on a weighing machine that is kept in a lift. If the mass of the man is 60 kg and the reading of the weighing machine is 90 kg, then calculate the acceleration of the lift. 90G force is exerted on the upper surface of weighing machine. It is given that reading of weighing machine is more than mass of the man. That means lift is going upwards. Let's say acceleration of the lift is A. Then net acceleration upwards will be A plus G. Now we can form the equation as m into A plus G is equal to 90G. M is given as mass of the man 60 kg. So 60 into A plus G is equal to 90G. So A comes out to be equal to G by 2. Second question. A man of mass 50 kg is standing on a weighing machine of mass 5 kg placed on the ground. Another weighing machine of mass 5 kg is placed on man's head, on top of which a block of mass 20 kg is kept, as shown in the figure. Calculate the reading of both weighing machines. This weighing machine is kept on the ground on which a man is standing. On top of man's head, another weighing machine is kept on which 20 kg block is kept. So we have to calculate the reading of these two weighing machines. We can do it verbally. How much force is exerted on upper surface of first weighing machine? That will be 20G plus 5G plus 50G. So that is 75G. How much force is exerted on the upper surface of second weighing machine? That will be 20G. So the answer is 75G and 20G will be the reading of these two weighing machines respectively. A spring balance measures the force exerted by an object on its hook. Let us see a couple of questions based on it. First question, a block of mass 2 kg is suspended through two light spring balances A and B. What will be the reading of A and B? These are two light spring balances. That means we can neglect their mass. 2 kg is suspended from spring balance B. We have to calculate their readings. Look at the hook of spring balance B. How much is the force exerted by 2 kg mass? It will be 2g. So reading of this spring balance will be 2g. Now look at the hook of spring balance A. How much is the force exerted by spring balance B and 2 kg mass? Since mass of spring balance B is negligible, so force exerted by it will be negligible. So reading of this spring balance will be 2g. So reading of both the spring balances will be 2g. Second question, an ideal pulley is suspended from a spring balance which is hanged from a wall. Masses of 1 kg and 2 kg are tied to two ends of a light string which passes over the pulley. The masses move due to gravity. During motion, calculate the reading of the spring balance. This spring balance is attached to wall. At its hook, an ideal pulley is hanged. Two masses 1 kg and 2 kg are tied to two ends of a string which pass over this ideal pulley. Now during motion of these blocks, we have to calculate the reading of this spring balance. During motion of these two blocks, force will be exerted on this hook and that will be equal to T plus T, that is 2T. So we have to calculate the value of 2T. These blocks are moving due to gravity. So heavier block will come down and lighter block will move up. Since this string is taut and it is of constant length, so distance traveled upwards by 1 kg block will be distance traveled downwards by 2 kg block. So their accelerations will be same. Let's say this is A. This is FBD of 1 kg block. T is the tension created on it by this string. This block is moving upwards, so net force will be upwards. It will be T minus M1G and that will be equal to M1A. M1 is given as 1 kg. So T minus G is equal to A. This is first equation. This is FBD of 2 kg block. This is moving downwards, so net force will be downwards and that will be M2G minus T is equal to M2A. M2 is given as 2 kg. So 2G minus T is equal to 2A. We can solve these two equations for T. So T comes out to be equal to 4G by 3. So reading of spring balance will be equal to 2T and that is equal to 8G by 3. Now let us understand constrained motion. Sometimes, while solving the equations of motion, the number of variables are one more than the number of equations available. In those cases, in all certainty, we are missing that one equation known as constraint relation. There are two methods to figure out constraint relation. First is considering segments of a string or strings, and the second is method of virtual work. We will understand both the methods with the help of this question. Two blocks of masses m1 and m2 are attached at two ends of an inextensible string which passes over an ideal pulley. If m1 is greater than m2, then find the acceleration of each block, the tension in the string. Two blocks m1 and m2 are attached to two ends of a string which is light and inextensible. Light means we don't have to consider its weight, and inextensible means its length is fixed. It doesn't change. This string is passing over an ideal pulley. Ideal pulley means it is massless and frictionless. We have to figure out acceleration of these blocks and tension in this string. It is given that m1 is greater than m2. So m1 will come down and m2 will go up. Consider their accelerations are a1 and a2 respectively. Tension in the string is T. This is a video of block M2. T is working upwards due to string. M2G is its weight. Since this block is moving up, so net force will be upwards, and that will be T minus M2G. So T minus M2G will be equal to M2A2. This is a video of block M1. T is working upwards due to string. M1G is its weight. Since this block is moving down, so net force will be downwards, and that is m1g minus t. So m1g minus t is equal to m1a1. Now there are three variables, a1, a2 and t, and we have got only two equations. So time to figure out that constraint relation, that is relation between a1 and a2. First method, considering segments of strings. Consider at t is equal to 0, length of this segment is x1 and length of this segment is x2, where these are the points where a string starts touching this pulley. As the time passes, this block moves down and this block moves up. So x1 increases and x2 decreases. We will consider increase as positive and decrease as negative. Amount of increase in x1 will be equal to amount of decrease in x2, as this is inextensible string whose length is fixed. So at any point of time, x1 plus x2 will be equal to constant. Differentiating both sides of this equation with respect to time, we get dx1 by dt plus dx2 by dt is equal to 0, where dx1 by dt is velocity of block m1 and dx2 by dt is velocity of block m2. We are considering increase as positive and decrease as negative. So dx1 by dt we will write plus v1 and dx2 by dt we will write minus v2. So v1 minus v2 is equal to 0 or v1 is equal to v2. Now differentiating this equation again with respect to time, we get d square x1 upon dt square plus d square x2 upon dt square is equal to 0. This is acceleration of block m1 and this is acceleration of block m2. Again, we will consider the same thing as increase of length as positive and decrease of length as negative. So we will write a1 as positive and a2 as negative. So putting these values in this equation, we get a1 minus a2 is equal to 0 or a1 is equal to a2. This is our constraint relation. Now we can solve equations 1, 2 and 6 to get a1 is equal to a2 is equal to m1 minus m2 upon m1 plus m2 times g, and t is equal to 2m1 m2 upon m1 plus m2 times g. Second method, method of virtual work. This method is based on the principle that summation of total work done by the system is equal to 0. Work done is equal to force into displacement in the direction of force. Consider this scenario again. This block is moving upwards. Tension is also applied upwards. That means applied force and its displacement both are in same direction. So work done will be positive and it will be equal to T into x2. In case of block M1, tension is applied upwards and block is moving downwards. That means applied force and its displacement are in opposite directions. So work done will be negative. It will be equal to T into minus x1. Take T common. So it will be T into x2 minus x1 is equal to 0. That means either T is equal to 0 or x2 minus x1 is equal to 0. T is not equal to 0, so x2 minus x1 is equal to 0. Now differentiate both sides of this equation with respect to time. We get dx2 by dt minus dx1 by dt is equal to 0. This is velocity of block m2 and this is velocity of block m1. So v2 minus v1 is equal to 0 or v2 is equal to v1. Now differentiate again this equation with respect to time. So we get d square x2 upon dt square minus d square x1 upon dt square is equal to 0. This is acceleration of block m2 and this is acceleration of block m1. And that is equal to a2 minus a1 is equal to 0 or a2 is equal to a1. So we have got constraint relation. Solving equations 1, 2 and 6, we get value of a1, a2 and t. This method is quicker than the previous method. So here onwards, we will apply this method to solve the equations of motion. To apply this method, we need to consider two variables. One, tension in the string, and second, displacement or velocity or acceleration of the connected object. And we need to take component of displacement or velocity or acceleration of connected object in the direction of tension of the string. Now let us see two questions based on string constraint. First question, find the acceleration of the blocks A and B in the given figure. Assume strings are light and pulley is ideal. This is the given figure. Block A is attached to this string and block B is attached to this string. These two pulleys are ideal. This pulley is fixed to the wall and this pulley is free to move up or down. Suppose tension in this string is T. It will be T everywhere. Suppose this block is moving upwards with acceleration a1. When this moves up, length of this segment will decrease and length of this segment will increase. As a result, this pulley will come down and attached block B will also come down. Suppose B moves downwards with acceleration a2. This is FBD of block A. Tension T works on it due to this string. M1G is its weight. Since this is moving upwards, so net force on it will be upwards and that will be T minus M1G. So we can write equation of motion as T minus M1G is equal to M1A1. M1 is given as 2 kg. So it will be T minus 2G is equal to 2A1. This is first equation. This is FBD of this pulley. Tension T is working on this string on both the sides. So tension on this string will be T plus T, that is 2T. This is a BD of block B. Tension 2T is working on it due to this string. M2G is its weight. Since this block is moving downwards, so net force on it will be downwards and that will be M2G minus 2T. So equation of motion will be M2G minus 2T is equal to M2A2. M2 is given as 1 kg. So G minus 2T is equal to A2. This is second equation. We have got three variables A1, A2 and T and only two equations. So we need to figure out that constraint relation, that is relation between A1 and A2. Focus on this block. This is connected to a string whose tension is T. This block is moving upwards. That means force and displacement both are in same directions. So work done will be positive. We can write T into A1. Focus on block B. This is connected to a string whose tension is 2T. This block is moving downwards. That means force and displacement are in opposite directions. So work done will be negative. We can write this as 2T into minus A2 is equal to 0. Take T common. So it will be T into A1 minus 2A2 is equal to 0. So either T is equal to 0 or A1 minus 2A2 is equal to 0. Since T is not equal to 0, so A1 minus 2A2 is equal to 0 or A1 is equal to 2A2. This is third equation. This is constraint relation. Now we can solve equations 1, 2 and 3 to get A1 and A2. A1 is equal to minus 2g by 3 and A2 is equal to minus g by 3. Negative sign suggests that the assumption that A is moving upwards and B is moving downwards is wrong. Actually, A is moving downwards and B is moving upwards. Second question, in the given figure, block M1 slides down a frictionless inclined plane. Find the accelerations of the blocks. Assume strings are light and pulleys are ideal. This is the given figure. Block M1 is connected to this string whose other end is fixed. Block M2 is connected to this string. These two pulleys are ideal. This pulley is fixed and this pulley is free to move in this direction. Suppose tension in this string is T. It will be T everywhere. Suppose block M1 comes down the plane with acceleration A1. When this moves downwards, this pulley will also move downwards. So length of this segment will increase or length of this segment will decrease. So block M2 will move upwards. Suppose block M2 moves upwards with acceleration A2. This is a BD of block M1. Its weight M1g works vertically downwards. Normal reaction by this plane works perpendicular to the plane. T is the tension that works on it due to this string. We will resolve its weight into two components, one along the plane, another perpendicular to the plane. Along the plane component will be m1g sine theta, where theta is angle of inclination of this plane. Perpendicular to the plane component will be m1g cos theta. Since this block is moving downwards, that means net force is working downwards, and that is m1g sine theta minus t. So we will form equation of motion as m1g sine theta minus t is equal to m1 a1. The other equation will be n is equal to m1g cos theta. This is a BD of pulley P. P is the tension force working on this string on both the sides. So tension force on this string will be T plus T, that is 2T. This is a BD of block M2. 2T is the tension force working on it due to this string. M2G is its weight. Since this block is moving upwards, so net force is upwards, and that is 2T minus M2G. So equation of motion will be 2T minus M2G is equal to M2A2. We have got three equations and we have got four variables, and the variables are A1, A2, T and N. We will apply method of virtual work done to figure out constraint relation. Focus on block M1. It is connected to a string whose tension is T. Block is moving downwards. That means force and displacement are in opposite directions. So work done will be negative. We will write T into minus A1. Now focus on this block M2. It is connected to a string whose tension is 2T. Block is moving upwards. That means force and displacement are in same directions. So work done will be positive. We will write 2T into A2. Summation of these two will be equal to 0. Take T as common, so it will be T into minus A1 plus 2A2 is equal to 0. That means either T is equal to 0 or minus A1 plus 2A2 is equal to 0. Since T is not equal to 0, so minus A1 plus 2A2 is equal to 0 or A1 is equal to 2A2. So we have got our constraint relation. Now we can use equation 1, 3 and 4 to figure out A1 and A2. Now we know how to figure out string constraint relation. Let us talk about wedge constraint. Suppose this wedge is moving horizontally with velocity v. A vertical rod is moving vertically downwards with velocity u. Its tip is touching the wedge. The condition that its tip should keep touching the wedge is components of their velocities perpendicular to this plane should be equal, and that is u cos theta is equal to v sin theta or u is equal to v tan theta, where theta is angle of inclination of this plane. Now let us understand friction. Suppose a man is pushing a heavy object towards the wall. He is applying a horizontal force F on the object. but he is not able to move the object. At this point of time, weight of this object is mg, that is working at its geometrical center. N is the normal reaction applied by the floor on the object. These two vertical forces counter each other. Then what is that force that opposes the tendency of this object to slide? That force is called as friction force. It acts between the contact surfaces of two objects, and its direction is tangential to the contact surfaces. It makes action-reaction pair. That means if the ground applies friction force Fs in this direction on the object, then object applies equal and opposite friction force on the ground in this direction. At this point of time, friction force is called as static friction. It is represented by Fs. Suppose F is increased and still object doesn't move, then Fs is increased. If F is increased further and still object doesn't move, that means Fs is increased further. But there is a limit to which Fs is increased. Beyond that, it cannot. That limit is called as limiting friction. It is represented by Fsm. That means maximum static friction. If the value of applied force is more than limiting friction, then this object starts sliding. When the object starts sliding, the friction force is called as kinetic friction. It is represented by Fk. It is experimentally seen that limiting friction varies linearly with normal reaction, and it is given by Fsm is equal to μs into n. μs is coefficient of static friction. N is equal to mg. So Fsm is equal to μs mg. Similarly, Fk is equal to μk into n, or Fk equal to μk into mg, where μk is equal to coefficient of kinetic friction. Relation between static friction and limiting friction is Fs is less than or equal to Fsm. Relation between static friction and kinetic friction is Fs is greater than or equal to Fk. Relation between coefficient of static friction and coefficient of kinetic friction is μs is greater than or equal to μk. This is the graph between applied force F and friction force. Initially, when the object doesn't move, friction force increases linearly. When object starts moving, friction force drops to a certain level and then becomes constant. There are different types of frictions. For example, dry friction, fluid friction, internal friction, rolling friction, etc. In this chapter, we will focus on dry friction, which occurs between the contact surfaces of two solid objects. It is of two types, static friction and kinetic friction. We will study fluid friction in another chapter. Advantages and disadvantages of friction. The biggest advantage is because of the friction, we are able to walk and run. Disadvantage is it causes loss of energy, and it causes wear and tear to the contact surfaces of the objects. Now let us see laws of friction. Laws of friction are summarized in 4 points. First point, if the bodies slip over each other, force of friction is given by Fk is equal to μk into n. We have already seen that when the sliding starts, force of friction is called as kinetic friction. It is given by Fk is equal to μk into n, where μk is equal to coefficient of kinetic friction and n is the normal reaction force. Second point, the direction of kinetic friction on a body is opposite to the velocity of this body with respect to the body applying the force of friction. Suppose force F is applied on a block. As a result, it starts moving on this surface towards right with velocity v. Then this surface will apply friction force Fk on this block in the direction opposite to its motion. Third point, if the bodies do not slip over each other, the force of friction is given by Fs is less than or equal to μs into n. The direction and magnitude of static friction is such that the condition of no slipping between the bodies is ensured. Suppose a horizontal force F is applied on a block, but the block does not move. That means Friction force on this block by the surface will be applied in such a direction so that it opposes the tendency of this block to slide in the direction of applied force. Fourth point, the frictional force Fk or Fs does not depend on the area of contact as long as the normal force is same. Suppose there are two identical bricks. They are kept on a surface, first like this and second one like this. In first case, area of contact between the two objects is more, and in second case, area of contact between the two objects is less. But Fs or Fk in both the cases will be same, as Fs is less than or equal to mu s into n and Fk is equal to mu k into n. So they depend on n, and we know that n is equal to mg. So Fs or Fk will depend on mass of these objects. Since these bricks are identical, so their mass will be same. So Fs or Fk will be same in both the cases. Coefficient of static friction μs depends on the material of the objects and the roughness of two surfaces in contact. Now let us see angle of friction and angle of repose. Angle of friction lambda is the angle between vector r and vector n. Vector r is vector sum of normal reaction and limiting friction. Limiting friction is represented by Fsm, and Fsm is equal to mu s into n, where mu s is coefficient of static friction and n is normal reaction. In this right angle triangle, tan lambda is equal to Fsm upon n. Fsm is equal to mu s into n. So tan lambda is equal to mu s into n upon n, or tan lambda is equal to mu s, or lambda is equal to tan inverse mu s. So angle of friction depends only on the coefficient of static friction. Angle of repose. Suppose an object is kept on an inclined plane whose angle of inclination is slowly increased. At certain angle theta, this object will start sliding down the plane due to its own weight. That angle of inclination of the plane is called as angle of repose. From this figure, it is clear that angle of repose theta is equal to angle of friction lambda. Now let us see some questions based on friction. First question, a block of mass 2.5 kg is kept on a rough horizontal surface. It is found that the block does not slide if a horizontal force less than 15 Newton is applied to it. Also, it is found that it takes 5 seconds to slide through the first 10 meter if a horizontal force of 15 Newton is applied and the block is gently pushed to start the motion. Taking g is equal to 10 meter per second square, calculate the coefficients of static and kinetic friction between the block and the surface. This block is kept on a rough surface. Its weight works vertically downwards at its geometrical center. N is the normal reaction by the surface on this block. This block is pulled by a horizontal force F. It is given that when F is less than 15 Newton, this block doesn't move. When F is equal to 15 Newton, this block starts sliding. That means 15 Newton is limiting friction. We represent it by Fsm, that is maximum static friction. So Fsm is equal to 15 Newton. Formula for Fsm is equal to mu s into n, where mu s is coefficient of static friction, n is normal reaction, n is equal to mg. So Fsm is equal to mu s mg, or mu s is equal to Fsm upon mg. Fsm is 15 Newton, m is given as 2.5 kg, g we can take as 10 meter per second square. So mu s comes out to be equal to 0.6. When F is 15 Newton, this block starts sliding. So the friction will be now kinetic friction. So we can calculate its acceleration by this line. Applying the second equation of motion in a straight line, x is equal to x0 plus u0t plus half at square. x0 is initial displacement, that is 0. u0 is 0 because block was initially at rest. So x is equal to 1 by 2 at square, or a is equal to 2x upon t square. X is given as 10 meter and t is given as 5 seconds. So A comes out to be equal to 0.8 meter per second square. Kinetic friction will oppose the motion, so it will work in this direction. So resultant force will be F minus Fk. Fk is given by mu k n, where mu k is coefficient of kinetic friction, n is normal reaction, n is equal to mg. So Fk is equal to mu k mg. Now resultant force is F minus Fk, and that is equal to ma. So F minus mu k mg is equal to ma, or mu k mg is equal to F minus ma, or mu k is equal to F minus ma upon mg. We can put the values of F, m, a and g. F is equal to 15 Newton, m is equal to 2.5 kg, a we have found out as 0.8 meter per second square, g we can take 10 meter per second square. So mu k comes out to be 0.52. Second question, a body is in limiting equilibrium on a rough inclined plane at an angle of 30 degree with horizontal. Calculate acceleration with which the body will slide down when inclination of the plane changes to 45 degree. Take g is equal to 9.8 meter per second square. Suppose a block is kept on inclined plane. Angle of inclination is 30 degrees. This block is in limiting equilibrium. That means it is about to slide. Static friction force on it will work up the plane, opposing block's tendency to slide down. We will equate various forces working on this block along the plane and perpendicular to the plane. mg is its weight that works perpendicularly downwards at its geometrical center. Its component along the plane will be mg sin 30 and perpendicular to the plane will be mg cos 30. N1 is normal reaction by this surface on the block. So we will say Fs is equal to mg sin 30 and N1 is equal to mg cos 30. In case of limiting equilibrium, Fs is equal to Fsm, that is limiting friction. So Fsm is equal to mg sin 30 and N1 is equal to mg cos 30. We know the formula for limiting friction is equal to mu s into normal reaction. We will put values of Fsm and N1 from here to get mu s is equal to 1 by root 3. When angle of inclination of the plane changes to 45 degrees, this block will start accelerating downwards. That means net force on this block will be downwards. Component of weight of this block in this case will be along the plane will be mg sin 45 and perpendicular to the plane will be mg cos 45, and N2 will be mg cos 45. So net force downwards will be mg sin 45 minus Fs, and that will be equal to ma. That will be equation of motion. Fs is equal to mu s into N2 and N2 is equal to mg cos 45. So we will put various values in this to get value of A as 2.93 meter per second square. Third question, length of a uniform chain is L and coefficient of static friction is mu between the chain and the tabletop. Calculate the maximum length of the chain which can hang from the table without sliding down. Suppose initially chain was completely on the table. You hold its one end and start dragging it down the table slowly. As the hanging part keeps increasing, its weight also keeps increasing. At a certain point of time, due to increasing weight, this chain starts sliding down on its own. We have to calculate that maximum length of the hanging part x. At that point, limiting friction of this chain will be equal to weight of the hanging part. Suppose mass of the chain is m, then mass per unit length will be equal to m by L. Limiting friction Fsm will be equal to mu into NAB, and NAB will be equal to weight of part AB of the chain. So we will calculate weight of part AB of the chain, and that will be equal to mass per unit length into length of part AB, that will be L minus x into G. So mu into m by L into L minus x into G will be equal to weight of the hanging part of the chain, and that will be equal to mass per unit length into length of the hanging part into g. So x comes out to be equal to mu L upon 1 plus mu. Now let us understand how to solve two-block system. We will consider 4 scenarios. In all the 4 scenarios, there are 2 blocks, block A and block B. Block A is kept on block B. In scenario 1 and 2, floor is smooth. In scenario 3 and 4, floor is rough. In scenario 1 and 3, a horizontal force F is applied on lower block. In scenario 2 and 4, a horizontal force F is applied on upper block. In few questions, you will see 3-block system. You can solve them easily if you know how to solve 2-block system. We will understand 4 scenarios by 4 questions. First question, in the given figure, block A is placed on block B and both are placed on a smooth horizontal floor. An increasing horizontal force F is applied on the lower block. Part A, when does block A start slipping on block B? What will be the force F and acceleration just before the slipping starts? Part B, when F is increased beyond the value obtained in part A, what will be the acceleration of block A? It is given that block A is kept on block B. There is no friction force between block B and the floor, as floor is smooth. There is friction force between block A and block B. Coefficients of static friction and kinetic friction are given. An increasing horizontal force F is applied on block B. Mass of block A is given as 5 kg and mass of block B is given as 10 kg. We have to answer these two parts. First step, find out friction forces on two blocks and their directions. Force F is working on block B. There is no external force working on block A. Still, block A is moving along with block B in forward direction. That means there must be a force working on it in forward direction, and that force is none other than friction force. So block A is moving in forward direction only because of friction force. It is working on its lower surface which is in contact with block B and it is represented by Fs. On upper surface of block B, which is in contact with block A, an equal and opposite friction force works because they make action-reaction pair. Next, we will calculate magnitude of Fs, which is less than or equal to μs into N1. N1 is equal to mag. So Fs is less than or equal to μs into ma into g. Value of μs is given as 0.25. Value of ma is given as 5 kg. G we can take 10 meter per second square. So Fs is less than or equal to 12.5 Newton. When Fs is equal to 12.5 Newton, that will be limiting friction. Second step, find out maximum acceleration of the block which is moving due to friction force only. Block A is moving due to friction force only. It can attain a maximum acceleration AAM is equal to limiting friction upon its mass. Limiting friction is 12.5 Newton and its mass is 5 kg. So block A can attain a maximum acceleration of 2.5 meter per second square. Third step, sequence of slipping. Block B is kept on smooth floor, so it will start slipping first with block A on it. Both blocks combined will start accelerating due to increasing force till their acceleration is 2.5 meter per second square. When force is increased further, block B will try to accelerate beyond this, but block A cannot. As a result, block A will start slipping on block B. Part A. Just before block A starts slipping on block B, they are moving with acceleration 2.5 meter per second square. Till that moment, they can be treated as a single body. At that moment, force F will be equal to ma plus mb into AAB. ma is given as 5 kg, mb is given as 10 kg, and AAB is equal to 2.5 meter per second square. So F comes out to be equal to 37.5 Newton. And acceleration A is 2.5 meter per second square. Part B. When force is increased beyond 37.5 Newton, block B will accelerate beyond 2.5 meter per second square, but block A cannot. As a result, block A will start slipping on block B. Now we will treat them as different bodies. We know that block A is moving only due to friction force. When the slipping starts, we will call this friction as kinetic friction. It can be calculated by the formula Fk is equal to mu k into ma into g. Mu k is given as 0.10, ma is given as 5 kg, g we can take 10 meter per second square. So Fk is equal to 5 Newton and its acceleration will be Fk upon ma, that is 5 upon 5 or 1 meter per second square. Second question. In the given figure, block A is placed on block B and both are placed on a smooth horizontal floor. A horizontal force of 50 Newton is applied on block A. Part A. Will blocks move together or separately? What will be their accelerations? Part B. If horizontal force is 120 Newton, what will be their accelerations? It is given that block B is kept on a smooth floor. Block A is kept on block B. A horizontal force of 50 Newton is applied on block A. Mass of both the blocks is 10 kg. We have to answer these two parts. First step, find out the directions of friction forces and their magnitude. Block B is kept on a smooth floor. So block B will start sliding on the floor first in the direction of applied force F on block A. There is no external force working on block B. Still, it moves ahead in forward direction. So there must be some force working on it, and that is friction force. So block B moves only because of friction force. It works on its upper surface, which is in contact with block A. So this is shown by F. An equal and opposite friction force works on lower surface of block A, which is in contact with block B. Next, we will calculate magnitude of friction force, and that is equal to mu into N. N is the normal reaction that is working on this contact surface vertically upwards, and that will be equal to ma into g, that is working vertically downwards. So magnitude of friction force is equal to mu into ma into g. Value of mu is given as 0.5, ma is given as 10 kg, g we can take 10 meter per second square. So magnitude of friction force is equal to 50 Newton. Now we are ready to answer part A. Suppose both the blocks are moving together. So we can treat them as a single body on which an external force of 50 Newton is applied. We can calculate the acceleration of this single body, and that is equal to F upon ma plus mb. F is 50 Newton, ma is 10 kg and mb is 10 kg. So acceleration comes out to be equal to 2.5 meter per second square. Next we will calculate friction force on block B, because this block is moving only because of friction force. So FB is equal to MB into AAB. MB is 10 kg and AAB is 2.5 meter per second square. So FB comes out to be equal to 25 Newton, which is less than maximum friction force. So these two blocks will not be separated. They will move together. Condition that these two blocks will be separated, this force should be greater than 50 Newton. So we have answered part A. Will the blocks move together or separately? They will move together. What will be their accelerations? They will move with same acceleration, and that is 2.5 meter per second square. Part B. Now external force is 120 Newton in place of 50 Newton. So we will start all over again from here. Suppose both the blocks are moving together, so we will treat them as a single body on which external force of 120 Newton is applied. So acceleration of this common body will be equal to F upon ma plus mb. F is 120 Newton, ma is 10 kg and mb is 10 kg. So common acceleration of both the blocks is 6 meter per second square. Friction force on block B will be equal to mb into AAB. mb is 10 kg and AAB is equal to 6 meter per second square. So FB comes out to be equal to 60 Newton, which is more than maximum friction. So both the blocks will be separated. Now we will consider both the blocks as separate bodies and calculate their accelerations separately. Acceleration of block A will be equal to external force minus friction force upon its mass, and that is 120 minus 50 upon 10, that is 7 meter per second square. Acceleration of block B is equal to friction force upon its mass, so that is 50 Newton upon 10 kg. So acceleration of block B is equal to 5 meter per second square. Let us see remaining two scenarios with the help of two questions. Third question, block A is placed on block B as shown in the figure. An increasing horizontal force F is applied on block B. Part A. Find the maximum value of F so that both the blocks don't move. Part B. Find the maximum value of F so that block A does not slide on block B. Part C. If F is increased beyond the value obtained in Part B, what are accelerations of both the blocks? Part D. If F is equal to 15t, draw acceleration time graph. Block B is kept on a rough floor. Block A is kept on block B. An increasing horizontal force F is applied on block B. Mass of block A is 10 kg and mass of block B is 20 kg. Coefficient of static and kinetic frictions between these two contact surfaces is given. We have to answer these four parts. First step, we will calculate direction and magnitude of friction forces. Block B is kept on rough floor. That means there is some friction force working between block B and the floor. Block B is getting pulled in forward direction. That means it will move in forward direction. Floor will apply a friction force on this block in opposite direction. Let us say this is contact surface 1 and this is contact surface 2. So the friction force that floor applies on block B is represented by F2S. There is no external force working on block A, but still it will move in forward direction along with block B. That means there is some force working on it in forward direction, and that force is friction force. So block A will move only due to friction force. It will work on its lower surface in forward direction. It is represented by F1S. An equal and opposite force will work on block B on its upper surface, which is in contact with block A, because they make action-reaction pair. Now we know the direction of friction forces. Next, we will calculate magnitude of friction forces. F1S is less than or equal to mu S1 into N1. N1 is the normal reaction that will work vertically upwards on this contact surface. N1 is equal to Ma into G, that will work vertically downwards. Value of mu S1 is given as 0.15. Ma is given as 10 kg. We can take G as 10 meter per second square. So F1S is less than or equal to 15 Newton. Similarly, we can calculate F1K, which is kinetic friction. F1K is equal to mu K1 into Ma into G. Mu K1 is given as 0.10. Ma is 10 kg and G is 10 meter per second square. So F1K is equal to 10 Newton. F2S is less than or equal to mu S2 into N2. N2 is the normal reaction that will work vertically upwards on this contact surface. So N2 is equal to Ma plus Mb into G. Mu S2 is given as 0.25. Ma is given as 10 kg and Mb is given as 20 kg. G is 10 meter per second square. So F2S is less than or equal to 75 Newton. Similarly, we can calculate F2K, which will be equal to mu K2 into Ma plus Mb into G. Value of mu K2 is given as 0.20. So F2K is equal to 60 Newton. Now we are ready to answer part A. Find the maximum value of F so that both the blocks don't move. That maximum value of F will be equal to F2SM, which is working between block B and the ground. Its value will be equal to 75 Newton. Second step, calculate maximum acceleration of the block which is moving due to friction force only. Block A is moving due to friction force only. Its limiting friction is 15 Newton. So it can reach a maximum acceleration of F1S upon Ma, that is 15 Newton upon 10 kg, which is 1.5 meter per second square. Third step, sequence of slipping. When F is less than or equal to 75 Newton, both the blocks will remain stationary. When F is greater than 75 Newton, block B will start slipping on the floor, taking along block A with it. So both the blocks will move together till their acceleration is 1.5 meter per second square. Till that moment, we can consider them as a single body on which external force F is getting applied. Since both the blocks are moving, so we will consider kinetic friction force working on block B. So their acceleration will be AA is equal to AB is equal to F minus F2K upon MA plus MB. AA is equal to AB is equal to 1.5 meter per second square. We have to calculate the value of external force F. F2K we have calculated 60 Newton. MA is given as 10 kg. MB is given as 20 kg. So F comes out to be equal to 105 Newton. This is answer of part B. Find the maximum value of F so that block A does not slide on block B or both the blocks move together. When F is greater than 105 Newton, block B will start accelerating beyond 1.5 meter per second square. But block A cannot, as its maximum acceleration is 1.5 meter per second square. As a result, block A will start slipping on block B. Part C. When external force F is greater than 105 Newton, block A will start slipping on block B. We will consider them as separate bodies. So acceleration of block A is equal to F1K upon MA. F1K we have calculated as 10 Newton. MA is given as 10 kg. So acceleration of block A will be equal to 1 meter per second square, which is constant. Acceleration of block B is equal to F minus F1K plus F2K upon MB. That is F minus F1K we have calculated as 10 Newton and F2K we have calculated as 60 Newton. MB is given as 20 kg. So AB will be given by the formula F minus 70 upon 20 meter per second square. Part D, F is equal to 15t. We have to draw acceleration time graph. First, we will figure out various time intervals and then acceleration of both the blocks in those time intervals. When F is less than or equal to 75 newtons, both the blocks are not moving. Their acceleration is 0. Put F is equal to 15t. So 15t is less than or equal to 75 or t is less than or equal to 5 seconds. So between time interval t is equal to 0 to t is equal to 5 seconds, blocks are stationary. When F is greater than 75 Newton but less than 105 Newton, that means between time interval t is equal to 5 seconds to t is equal to 7 seconds, both the blocks are moving together and their acceleration is given by the formula t by 2 minus 2. When F is greater than 105 Newton, block A starts slipping on block B. Acceleration of block A is equal to 1 meter per second square and acceleration of block B is equal to F minus 70 upon 20. Put F is equal to 15t. So acceleration of B is given by the formula 3t by 4 minus 3.5 meter per second square. Now we have got time interval and acceleration of both the blocks in those time intervals. So we can plot a t graph easily. Fourth question. In the given figure, block A is kept on rough horizontal ground. Block A is placed on it. An increasing horizontal force F is applied on block A. Part A. Find maximum value of F so that none of the blocks move. Which block starts sliding first? Part B. Find accelerations of both the blocks for all values of F. It is given that block B is kept on rough floor. Block A is kept on block B. An increasing horizontal force F is applied on block A. Mass of both the blocks is 10 kg. Coefficients of static and kinetic frictions between these two contact surfaces is given. We have to answer these two parts. First step, find out direction and magnitude of friction forces. Force F is applied on block A. So block A will move in forward direction. A friction force will be applied on block A by block B in opposite direction. It is represented by F1s. Let us say this is contact surface 1 and this is contact surface 2. An equal and opposite force will be applied by block A on upper surface of block B as they make action-reaction pair. Since block B will move forward, so floor will apply a friction force on block B in opposite direction. It is represented by F2S. Now we know the directions of friction forces. Next, we will calculate magnitude of friction forces. F1S is less than or equal to mu S1 into N1, where N1 is normal reaction that works perpendicularly upwards on this contact surface. Weight of block A is MAG that works perpendicularly downwards. So N1 is equal to MAG. So F1S is less than or equal to mu S1 into MA into G. Value of mu S1 is given as 0.60. MA is equal to 10 kg. We can take G as 10 meter per second square. So F1S is less than or equal to 60 Newton. Similarly, we can calculate F1K. F1K is equal to mu1K into MA into G. Value of mu1K is given as 0.50. So F1K is equal to 50 Newton. F2S is less than or equal to mu2S into N2, where N2 is normal reaction that works perpendicularly upwards on this contact surface. Weight of these two blocks will be MA plus MB times G that will work perpendicularly downwards. So N2 is equal to MA plus MB into G. So F2S is less than or equal to M2S into MA plus MB times G. Value of mu2S is given as 0.20. MA and MB is 10 kg. Value of G is 10 meter per second square. So F2S is less than or equal to 40 Newton. Similarly, we can calculate F2K. F2K is equal to mu2K into MA plus MB times G. Value of mu2K is given as 0.10. So F2K comes out to be equal to 20 Newton. Second step, calculate the maximum acceleration of the block which is moving due to friction force only. Block B is moving due to friction force only. On its upper surface, block A is applying a friction force in forward direction. It is represented by F1S. When block B is accelerating, floor is applying kinetic friction on block B in opposite direction. It is represented by F2K. So maximum acceleration of block B is given by AB max is equal to F1SM minus F2K upon MB. F1SM we have calculated as 60 Newton and F2K is equal to 20 Newton. MB is 10 kg. So AB max is equal to 4 meter per second square. Third step, sequence of slipping. To know that which block starts slipping first, whether A on B or B on floor, we will see F1S and F2S. F1S is less than or equal to 60 Newton and F2S is less than or equal to 40 Newton. Since F2S is less than F1S, so block B will start slipping on the floor first. Now we are ready to answer part A. Find maximum value of F so that none of the blocks move. That maximum value of F is 40 Newton. Which block starts sliding first? Block B starts sliding first. When value of F is more than 40 Newton, block B starts slipping on the floor, taking block A along with it, till their acceleration reaches 4 meter per second square. Till that point of time, we can treat them as a single body on which external force F is applied. On its bottom surface, floor is applying kinetic friction F2K. So AA is equal to AB is equal to F minus F2K upon MA plus MB. Value of F2K is equal to 20 Newton. MA is equal to MB is equal to 10 kg. So F is equal to 100 Newton. That means when value of F is between 40 Newton to 100 Newton, blocks are moving together. When F is more than 100 Newton, block A will try to accelerate beyond 4 meter per second square. But maximum acceleration of block B is 4 meter per second square. As a result, block A will start slipping on block B. When F is greater than 100 Newton, block A will start slipping on block B. So we will treat them as separate bodies. In that case, acceleration of block A is equal to F minus F1k upon ma. Value of F1k is equal to 50 Newton, ma is equal to 10 kg. So AA is equal to F minus 50 upon 10. Acceleration of block B is equal to F1k minus F2k upon mb. Value of F1k is 50 Newton, value of F2k is 20 Newton, and mb is equal to 10 kg. So AB is equal to 3 meter per second square. Now we are ready to answer part B. When F is less than or equal to 40 Newton, both the blocks are stationary. So their accelerations will be equal to 0. When value of F lies between 40 Newton to 100 Newton, both the blocks will move together. So their accelerations will be same, and that is equal to F minus 20 upon 20 meter per second square. When value of F is more than 100 Newton, acceleration of block A is equal to F minus 50 upon 10 meter per second square, and acceleration of block B is equal to 3 meter per second square. Now let us solve previous year's JEE questions. First question, the coefficient of static friction between a wooden block of mass 0.5 kg and a vertical rough wall is 0.2. The magnitude of horizontal force that should be applied on the block to keep it adhere to the wall will be dash Newton. Take G is equal to 10 meter per second square. This question appeared in JEE Mains 2021. This is vertical wall and this is wooden block. A horizontal force F is applied on the wooden block to stop it from falling down. Mass of this block is given as 0.5 kg. Coefficient of static friction between the wall and the wooden block, μs, is given as 0.2. We have to calculate the value of F. This is FBD of the wooden block. Force F is applied on it in forward direction. N is the normal reaction applied by the wall on the wooden block. mg is its weight that works vertically downwards at its geometrical center. Since this block has a tendency to fall down, so friction force on it will work vertically upwards. It is represented by Fs. At translational equilibrium, we will equate horizontal force with horizontal force and vertical force with vertical force. In other words, summation of Fx is equal to 0 and summation of Fy is equal to 0. So F is equal to N and Fs is equal to mg. We know that Fs is less than or equal to μs into N. When Fs is equal to Fsm, Fsm is equal to μs into N. Putting the value Fs is equal to mg and N is equal to F, we get mg is equal to μs into F, or F is equal to mg upon μs. Now we can put the values given. M is given as 0.5 kg, G we can take 10 meter per second square, μs is given as 0.2. So F comes out to be equal to 25 Newton. So the answer is 25 Newton. Second question, the length of a metal wire is L1 when the tension in it is T1 and L2 when tension is T2. The natural length of the wire is. These are the options given. This question appeared in JEE Mains 2021. Suppose this is the wire that is hanged from the ceiling. Its natural length is L. Now a mass M1 is tied to its other end so that this wire gets stretched and its length becomes L1. Tension in the wire is T1. Now another mass M2 is attached to its other end so that length of this wire becomes L2 and tension in it is T2. We have to calculate its natural length L. As per Hooke's law, F is equal to minus Kx, where x is amount of deformation and F is applied force on the wire. In first case, deformation is L1 minus L. So we can write T1 is equal to minus K into L1 minus L, where K is some constant. This is our first equation. Similarly, we can write T2 is equal to minus K into L2 minus L. This is second equation. Now divide equation 1 by equation 2. We get T1 by T2 is equal to L1 minus L upon L2 minus L. Now we can apply componendo and dividendo law. So T1 plus T2 upon T1 minus T2 is equal to L1 minus L plus L2 minus L divided by L1 minus L minus L2 plus L. So we can solve for L, which comes out to be equal to L1 T2 minus L2 T1 upon T2 minus T1. So the option B is correct. Third question, a block kept on a rough inclined plane as shown in the figure remains at rest up to a maximum force 2 Newton down the inclined plane. The maximum external force up the inclined plane that does not move the block is 10 Newton. The coefficient of the static friction between the block and the plane is. These are the options given. Take G is equal to 10 meter per second square. This is the figure given. This question appeared in JEE Mains 2019. We will consider two cases. Case 1, when 2 Newton force is applied on the block down the plane. And case 2, when 10 Newton force is applied on the block up the plane. This is FBD of the block in case 1. If the applied force is more than 2 Newton, this block will slide down. So friction force will work on this up the plane. It is represented by Fs1. N1 is normal reaction by the plane. Weight of this block is mg that works perpendicularly downwards at its geometrical center. We will resolve this weight into two components, one along the plane, another perpendicular to the plane. Along the plane component will be mg sin 30 and perpendicular to the plane component will be mg cos 30. At translational equilibrium, we will equate forces along the plane and perpendicular to the plane. So along the plane equation will be Fs1 is equal to mg sin 30 plus 2. That is first equation. And perpendicular to the plane equation will be N1 is equal to mg cos 30. This is second equation. We know that Fs1 is equal to mu s into N1. Value of Fs1 and N1 we will put from here to get equation number 3. This is FBD of the block in case 2. If the applied force is more than 10 Newton, this block will move upwards. So friction force on it will work along the plane downwards. This is represented by Fs2. N2 is normal reaction applied by the plane. Mg is weight of the block. It is resolved into two components, one along the plane, another perpendicular to the plane. Along the plane component is mg sin 30 and perpendicular to the plane component is mg cos 30. At translational equilibrium, we will equate forces along the plane and perpendicular to the plane. So along the plane equation will be Fs2 plus mg sin 30 is equal to 10. This is equation number 4. Perpendicular to the plane equation will be N2 is equal to mg cos 30. That is equation number 5. We know that Fs2 is equal to mu s into N2. Value of Fs2 and N2 we will put from here to get equation number 6. Now we can solve equation number 3 and equation number 6 to get value of mu s is equal to root 3 by 2. So the correct option is option B. Fourth question, a block of mass 5 kg is first pushed in case A and second pulled in case B by a force F is equal to 20 Newton, making an angle of 30 degree with the horizontal as shown in the figures. The coefficient of friction between the floor and the block is mu is equal to 0.2. The difference between the accelerations of the block in case B and case A will be. These are the options given. G is equal to 10 meter per second square. These are the figures given. This question appeared in JEE Mains 2019. This is FBD of the block in case A. We can resolve external force F along horizontal and vertical directions. Its horizontal component will be F cos 30 and vertical component will be F sin 30. Since this block is moving in forward direction, so friction force on it will work in opposite direction. It is represented by Fk1, that is kinetic friction. Weight of this block is mg, that will work vertically downwards at its geometrical center. N1 is normal reaction applied by the floor that will work vertically upwards. Vertical forces will counter each other and this block will accelerate in forward direction due to net force in forward direction. Let's say acceleration of this block is a1. So we can write equation of motion as m into a1 is equal to net force in forward direction and that is F cos 30 minus Fk1. This is first equation. Also, n1 is equal to mg plus f sine 30. This is second equation. Fk1 is equal to mu k into n1. From equation 1, we can write a1 is equal to 1 by m into f cos 30 minus fk1. Fk1 is equal to mu k into n1 and n1 is equal to f sine 30 plus mg. Now we can write value of sine 30 is equal to 1 by 2, value of cos 30 is equal to root 3 by 2, value of f is given as 20 Newton, mu k is given as 0.2. So A1 we will find out as 1 by 5 into root 3 f by 2 minus 0.1 f minus 10. Value of f we can put as 20 Newton to simplify it further. Let's say this is equation number 3. This is FBD of the block in case B. We can resolve external force F along horizontal and vertical directions. Its horizontal component will be F cos 30 and vertical component will be F sin 30. Since this block is moving in forward direction, so friction force on it will work in opposite direction. It is represented by Fk2, that is kinetic friction. Weight of this block is mg, that will work vertically downwards at its geometrical center. N2 is normal reaction applied by the floor. It will work vertically upwards. Vertical forces will counter each other and this block will accelerate in forward direction due to net force in forward direction. Let's say acceleration of this block is A2. So we can write equation of motion as m into A2 is equal to net force in forward direction and that is F cos 30 minus F2k. This is equation number 4. Also N2 plus F sin 30 is equal to mg. That is equation number 5. We know that Fk2 is equal to mu k into N2. From equation 4, we can write A2 is equal to 1 by m into F cos 30 minus Fk2. Fk2 is equal to mu k into N2 and N2 is equal to mg minus F sin 30. So A2 is equal to 1 by m into F into cos 30. Value of cos 30 is root 3 by 2 minus mu k into mg minus F sin 30. Value of sin 30 is 1 by 2. We can put F as 20 Newton, m is given as 5 kg, g we can take 10 meter per second square. So A2 is equal to 1 by 5 into root 3 f by 2 minus 10 plus 0.1 f. This is equation number 6. We have to find out A2 minus A1 and that comes out to be equal to 0.8 meter per second square. So the correct option is option B. Fifth question, a boy pushes a box of mass 2 kg with a force F is equal to 20I plus 10J Newton on a frictionless surface. If the box was initially at rest, then dash meter is displacement along the x-axis after 10 seconds. This question was asked in JEE Mains 2021. F is equal to 20I plus 10J. That means Fx is equal to 20I and Fy is equal to 10J. Acceleration along x-axis is equal to Fx upon m. Magnitude of Fx is 20 Newton. M is given as 2 kg. So acceleration along x-axis is equal to 10I. We can calculate displacement of the box along the x-axis by applying second equation of motion in a straight line. X is equal to x0 plus v0t plus 1 by 2 ax into t square. Initial displacement was 0. Initial velocity is 0 as the box was at rest. Ax is equal to 10 meter per second square. T is given as 10 seconds. So x comes out to be equal to 500 meter and that is the answer. So we will fill 500 here. Sixth question, a small block starts slipping down from a point B on an inclined plane AB, which is making an angle theta with the horizontal. Section BC is smooth and the remaining section CA is rough with a coefficient of friction mu. It is found that the block comes to rest as it reaches the bottom point A of the inclined plane. If BC is equal to 2AC, the coefficient of friction is given by mu is equal to k tan theta. The value of k is. This is the figure given. This question was asked in JEE Mains 2020. Section BC is smooth and section CA is rough. A block starts sliding down from point B. It starts accelerating till it reaches point C. Then between C to A, it decelerates due to friction force. Finally, at point A, it comes to rest. That means its velocity at A is 0. We will calculate coefficient of friction mu and then compare its value with mu is equal to k tan theta to get the value of k. Between section BC, let's say acceleration of the block is a1. mg is weight of the block that works vertically downwards at its geometrical center. Its component along the plane will be mg sin theta and perpendicular to the plane will be mg cos theta. N1 is normal reaction applied by the plane. We can write equation of motion as ma1 is equal to mg sin theta. This is equation number 1. And n1 is equal to mg cos theta. This is equation number 2. From equation 1, E1 is equal to g sin theta. Next, we will calculate the velocity of block at point C. Applying third equation of motion in a straight line, BC square is equal to VB square plus 2 into A1 into BC. VB is equal to 0 as the block was at rest at point B. So VC square is equal to 2g sin theta into BC. This is equation number 3. Between section CA, let's say acceleration of the block is A2. mg is weight of the block that works vertically downwards. Its component along the plane will be mg sin theta and perpendicular to the plane will be mg cos theta. N2 is normal reaction applied by the plane. Since this block is accelerating downwards, so friction force on it will work up the plane. It is represented by Fk. We can write equation of motion as ma2 is equal to mg sin theta minus Fk. This is equation number 4. And N2 is equal to mg cos theta. This is equation number 5. We know that Fk is equal to mu into N2. Putting these values of Fk and N2 in equation number 4, we get A2 is equal to g into sin theta minus mu cos theta. This is equation number 6. Next, we will calculate velocity of the block at point A, which is given as 0. Applying third equation of motion in a straight line, VA square is equal to VC square plus 2 into A2 into AC. VA is equal to 0, that is given. VC square is equal to 2g sin theta into BC. It is given that BC is equal to 2AC. So putting these values, we get 0 is equal to 2g AC into 3 sin theta minus mu cos theta. So either g is equal to 0 or AC is equal to 0 or 3 sin theta minus mu cos theta is equal to 0. Since g is not equal to 0 and AC is not equal to 0, so 3 sin theta minus mu cos theta is equal to 0, which gives mu is equal to 3 tan theta. Now compare this value of mu with mu is equal to k tan theta. So it gives the value of k as 3, which is our answer. Seventh question, a block of mass m slides on the wooden wedge, which in turn slides backward on the horizontal surface. The acceleration of the block with respect to the wedge is. These are the options given. Given small m is equal to 8 kg, capital M is equal to 16 kg, assume all the surfaces shown in the figure to be frictionless. This is the figure given. Small m is mass of the block, capital M is mass of the wedge. Angle of inclination of the plane is 30 degrees. This block accelerates downwards. This wedge accelerates backwards. This question appeared in JEE Mains 2021. Let's say acceleration of this block with respect to the wedge is A1. Acceleration of the wedge is A2. These two objects make a system. There is no external force applied on this system. As per Newton's second law of motion, F external is equal to m1 into A1 plus m2 into A2, where m1 and m2 are masses of two objects and A1 and A2 are their accelerations. F external is equal to 0. Let's say first object is this wedge. Its mass is capital M and its acceleration is A2. Second object is this block. Its mass is small m And net acceleration on this block along this direction will be, actually there are two accelerations working on this, one a1 and another a2. So net acceleration in this direction will be a2 minus a1 cos theta. Now putting the values given, capital M is given as 16 kg, small m is given as 8 kg, theta is equal to 30 degrees. So we get a2 is equal to root 3 by 6 a1. This is equation number 2. This is FBD of the block. mg is its weight. Component of weight along the plane will be mg sin theta and perpendicular to the plane will be mg cos theta. N is normal reaction applied by the plane. Net acceleration that will work along the plane, that is along the direction of motion, will be a1 minus a2 cos theta. So we can write equation of motion as m into a1 minus a2 cos theta is equal to mg sin theta. This is equation number 3. Now put the values of theta as 30 degrees and a2 is equal to root 3 by 6 a1. We get value of a1 as 2g by 3. This is our answer. So the correct option is option D. 8th question. Two blocks A and B of masses MA is equal to 1 kg and MB is equal to 3 kg are kept on the table as shown in the figure. The coefficient of friction between A and B is 0.2 and between B and the surface of the table is also 0.2. The maximum force F that can be applied on B horizontally so that the block A does not slide over the block B is dash Newton. These are the options given. Take G is equal to 10 meter per second square. This is the figure given. This question appeared in JEE Mains 2019. First step is to find out direction and magnitude of friction forces. There is no external force applied on block A. Still, it will move in forward direction along with block B due to friction force only. So, friction force will work on block A in forward direction on its lower surface which is in contact with block B. An equal and opposite friction force will work on upper surface of block B as they make action-reaction pair. Table will apply friction force on lower surface of block B in opposite direction to the applied force F. Now we know the directions of friction forces. Next, we will calculate magnitude of friction forces. Fs1 is less than or equal to mu s1 into n1 and n1 is equal to ma into g. So Fs1 is less than or equal to mu s1 into ma into g. Value of mu s1 is given as 0.2. ma is equal to 1 kg and g is given as 10 meter per second square. So Fs1 is less than or equal to 2 Newton. Fs2 is less than or equal to mu s2 into n2 and n2 is equal to mb into g. So Fs2 is less than or equal to mu s2 into mb into g. Value of mu s2 is given as 0.2. mb is equal to 3 kg and g is equal to 10 meter per second square. So Fs2 is less than or equal to 6 Newton. Second step, calculate maximum acceleration of block A which is moving due to friction force only. AA max is equal to F1 Sm upon Ma. Value of F1 Sm is equal to 2 Newton and Ma is equal to 1 kg. So AA max is equal to 2 meter per second square. When the value of external force is more than 6 Newton, block B will start sliding on the table, taking block A along with it, till their acceleration reaches 2 meter per second square. Till that point, we can treat them as a single body on which external force F is applied. So their acceleration AA is equal to AB is equal to F minus Fk2 upon Ma plus Mb. Value of Fk2 is equal to Fs1 plus Fs2, that is 8 Newton. So F comes out to be equal to 16 Newton, that is maximum external force is 16 Newton when block A will not start slipping over block B or block A will go along with block B. So our answer is 16 Newton. And the correct option is option A. Ninth question, an inclined plane is bent in such a way that the vertical cross section is given by y is equal to x square by 4, where y is in vertical and x is in horizontal direction. If the upper surface of this curved plane is rough with coefficient of friction mu is equal to 0.5, the maximum height in centimeter at which a stationary block will not slip downward is dash centimeter. This question was asked in JEE Mains 2021. We know that y is equal to x square by 4 is the equation of parabola. So this plane is parabolic. Its inner surface is rough. We have to find out maximum height at which a block is kept so that it doesn't slip downwards. This is FBD of the block. This line is tangent at point P. Let's say tangent makes an angle theta with the positive x-axis. mg is weight of the block that works vertically downwards at its geometrical center. We will resolve mg into two components, one along the tangent, another perpendicular to the tangent. Along the tangent component will be mg sin theta, and perpendicular to the tangent component will be mg cos theta. Since this block has tendency to slip down, so friction force on it will work up the plane along the tangent. It is represented by Fs. N is the normal reaction applied by the plane, which works perpendicular to the tangent. At translational equilibrium, we will equate forces along the tangent and perpendicular to the tangent separately. So we can say that Fs is equal to mg sin theta, this is equation number 1, and N is equal to mg cos theta, this is equation number 2. We know that Fs is equal to mu into N. So mg sin theta is equal to mu into mg cos theta, or mu is equal to tan theta. This is equation number 3. Equation of the plane is given by y is equal to x square by 4. So if we find dy by dx, that will represent slope of this tangent, and that is equal to tan theta. So dy by dx is equal to x by 2, or tan theta is equal to x by 2. This is equation number 4. From equation 3, tan theta is equal to mu. So mu is equal to x by 2, or x is equal to 2 mu. Value of mu is given as 0.5. So x is equal to 1 meter. Now we will put the value of x in this equation. So value of y comes out to be equal to 1 by 4 meter, or 25 centimeter. So this is our answer because h is equal to y. So h is equal to 25 centimeter is the answer. Last question. A block is moving on an inclined plane making an angle 45 degree with horizontal, and the coefficient of friction is mu. The force required to just push it up is 3 times the force required to just prevent it from sliding down. If we define n is equal to 10 mu, then n is. This question appeared in JEE Advanced 2011. We will consider given two cases one by one. In case 1, force F1 is applied on the block to push it up the plane. In case 2, force F2 is applied on the block to prevent it from sliding down. This is FBD of the block in case 1. Force F1 is applied on the block to push it up the plane. Since the block will move up the plane, so friction force on it will work down the plane. This is represented by Fs1. Weight of the block is mg, that works vertically downwards at its geometrical center. We will resolve it into two components, one along the plane, another perpendicular to the plane. Along the plane component will be mg sin 45, and perpendicular to the plane component will be mg cos 45. N1 is normal reaction applied by the plane which is perpendicular to the plane. At translational equilibrium, we will equate forces along the plane and perpendicular to the plane. So F1 is equal to mg sin 45 plus Fs1. This is equation number 1. And N1 is equal to mg cos 45. This is equation number 2. We know that Fs1 is equal to mu s into N1. From equation 1, F1 is equal to mg sine 45 plus Fs1. Put Fs1 is equal to mu s into N1 and N1 is equal to mg cos 45. So we get F1 is equal to 1 by root 2 mg 1 plus mu. This is equation number 3. This is ability of the block in case 2. Force F2 is applied on the block to prevent it from sliding down. Since the block has tendency to slide down, so friction force on it will work up the plane. It is represented by Fs2. Weight of the block is mg, that works vertically downwards at its geometrical center. We will resolve it into two components, one along the plane, another perpendicular to the plane. Along the plane component will be mg sine 45 and perpendicular to the plane component will be mg cos 45. N2 is normal reaction applied by the plane, which will work perpendicular to the plane. Now at translational equilibrium, we will equate forces along the plane and perpendicular to the plane separately. So we can say that F2 plus Fs2 is equal to mg sine 45. This is equation number 4. And N2 is equal to mg cos 45. This is equation number 5. We know that Fs2 is equal to mu s into N2. From equation number 4, F2 is equal to mg sine 45 minus Fs2 and Fs2 is equal to mu s into N2. N2 is equal to mg cos 45. So we get F2 is equal to 1 by root 2 mg into 1 minus mu. This is equation number 6. It is given that F1 is equal to 3F2. When we put this value, we get 1 plus mu upon 1 minus mu is equal to 3. Now we can apply componendo and dividendo law to get the value of mu. So 1 plus mu plus 1 minus mu upon 1 plus mu minus 1 plus mu is equal to 3 plus 1 upon 3 minus 1. So we get the value of mu is equal to 1 by 2. It is given that n is equal to 10 mu. So n is equal to 10 into value of mu is 1 by 2. So n comes out to be equal to 5. So this is the answer. In next video, we will start chapter number 5 and that is work, energy and power. If you have a question, you can ask me on my Discord server. If you have not subscribed my channel yet, please do so.